Hello everyone. In this video, I'll discuss what is a design scenario where the stuck-at fault model fails to detect a fault. Before we talk about this, let's do a quick refresher on the stuck-at fault model. The stuck-at fault model is the most fundamental and widely used fault model in the digital circuit testing. It assumes that there is a single fault in the circuit that causes a particular node or net to be permanently stuck to either logic 0 or 1, regardless of the intended signal value. By applying carefully chosen test vectors, designers attempt to force a node to a specific logic value and then observe how that value propagates to the primary outputs. By comparing the observed outputs with the expected fault-free outputs, the designer can determine whether a circuit is faulty or not. Stuck-at faults are very popular because they are simple to model, easy to generate tests for, and provide good coverage for many physical defects. However, there are certain circuit scenarios where this fault model fails to isolate and detect faults, even though a defect may exist in the circuit. One such scenario is known as the design with reconvergent fanout. Let's understand what is the reconvergent fanout in a circuit. Reconvergent fanout occurs when a signal in a digital circuit splits into multiple paths and then those paths later merge back together or reconverge at a downstream logic gate. Let's understand this concept using a simple example circuit. In this circuit, input A splits into two paths and propagates to two internal nodes X and Y. These two signals then merge back together at an XOR gate to produce output B. Now let's try to apply the stuck-at fault model to this circuit and see whether we can detect a fault where node A is stuck at logic 0. To detect a stuck-at 0 fault, we first attempt to drive a logic 1 on node A, assuming the circuit is fault-free. With A equals to 1, the circuit produces X equal to 0 and Y equals to 1. And the XOR of X and Y results in B equals to 1 at the output. Now let's assume node A is actually stuck at logic 0. So even though we try to drive A equals to 1, it remains at 0. As a result, the internal signals become X equal to 1 and Y equals to 0. Once again, the XOR of X and Y produces B equals to 1 at the output. Let's understand what happens here. Even though node A is faulty, the output doesn't change. The fault exists physically in the circuit, but it cannot be detected using stuck-at tests because the fault effect never propagates to the output. This happens because signal A fans out into two paths, and those paths later reconverge at the XOR gate. Since the two paths are logically correlated, the fault effects on each path cancel each other out at the point of reconvergence. This is why the reconvergent fanout circuit is considered a classic limitation of the stuck-at fault model. This is all for this video. Hope this is helpful.